Hi there. I'm going to work through a couple of these supplemental problems from the review. All of the solutions to the problems that are from the book are posted on Google Classroom already. So I'm going to work through this one and that one. Okay, so let's start with A. So just like normal, we're solving for x. And so what you want to ask yourself here is, what do we need to use to find x? So we've got two triangles. I'll refer to the big one as big triangle and the little one as little triangle. So to find x, first let's decide which triangle it's in. So x is in the small triangle. Now you'll notice that this angle is cut in half. So if we call this big angle theta, how big is this little angle? That would be theta over 2. So for the small triangle, the one that has x in it, the angle in question is theta over 2. And for this triangle, we have the opposite side. Sorry, we want the opposite side. We have the adjacent side. So the trig ratio we need is tangent. So what we're going to find first is the tangent value for that angle. So tangent of this angle is the opposite side from this angle divided by the adjacent side of this angle, x over 16. Now, do you know how big this angle is? I don't. So we're going to have to find the tangent value some other way than just plugging it into your calculator. And what we can do, because we have this big triangle, is we can find the tangent value not for theta over 2, which is the angle of the small triangle, but for theta, the angle of the big triangle. How does that help us? Well, recall there's a formula for tangent of theta over 2. That formula is this. So we have three options here. This one, with a large square root and a plus or minus. This one, that looks a lot simpler, but we need to know both cosine and sine. And this one that's almost exactly the same. Now, because I'm going to be able to find both cosine and sine of the original angle from the big triangle, I'm going to use this middle formula right here. So that's 1 minus cosine of theta over sine of theta. And again, I can find both of these values because theta is the angle of the big triangle and I know all the sides. So what would cosine of theta be? Well, here's the big angle. Adjacent, 16 divided by hypotenuse, 34. And it's not cosine of 16 over 34 or 16 over 34 times theta. Cosine of theta is just the fraction 16 over 34. It's a ratio. And then on the bottom is sine. So sine for this angle would be 30 over 34, opposite over hypotenuse. So that's the value for tangent of theta over 2, the angle from the small triangle. Now all we need to do is simplify it. Let's start by combining fractions on the top, and to do that, of course, we need a common denominator. So we're going to rewrite 1 as 34 34ths. Then we're going to take away 16 of those 34ths and see what's left over. By the way, feel free to reduce all of these fractions beforehand if you want to. So on top we have 18 34ths. On the bottom we have 30 34ths. So to divide by a fraction, you of course remember to flip and multiply. So that's 34 over 30. And now we reduce the 18 and the 30 reduce to 9 and 15, or even better, to 3 and 5. So this reduces to just 3/5. Okay. Let's remember what we just found. We found tangent of theta over 2. What does that mean? That means we found the ratio between the opposite and the adjacent sides for the triangle that has that angle theta over 2 in it. That's the little triangle right here. So to find the opposite side, we're going to use that ratio. So recall again this original equation we started with. Tangent of this angle equals opposite over hypotenuse, adjacent. Opposite over adjacent. So now all we need to do is plug in the actual value for tangent that we just found. So I'm going to rewrite this equation, and instead of writing tangent of theta over 2, I'm going to put in the 3/5 that we just solved for. So 3/5 equals x over 16, and now solve for x. You can cross multiply if you really want to, but I like to do things the easy way, so I'm just going to multiply both sides by 16. And there's my answer. 48/5, or as a decimal, would be a little less than 10, 9.6. And there's part A. If you want one that's similar to this to practice with, I leave for you question C. So here you'll notice we're starting off with values from the small triangle, and that angle is theta. So to find sides of the big triangle, which is what you're asked to do here, you'll need to consider one of the ratios for the angle 2 theta. So sine of 2 theta or cosine of 2 theta perhaps, whichever one will help you find that side y. Let's look at question C now. So this, you might or might not notice, fits the format of a quadratic equation. But to be able to solve it, we need to have all of the trig ratios therein represented only as either cosine or either sine or tangent, etc., etc. So what we're going to do is make some substitution so that we only have sines involved in our equation. That's going to make it easier to solve. So what you might remember is we have some Pythagorean identities. So this cosine squared is equal to something. Let's jot down the identity and see if we can remember what it's equal to. So we have the identity sine squared of x plus cosine squared of x equals 1. Pythagorean theorem, a squared plus b squared equals c squared. So what is cosine squared equaled? Well, isolate it on this side of the equation. So subtract the sine squared over to the other side, and you see that cosine squared equals 1 minus sine squared. So I'm going to come back to that original problem. And start by making that replacement. Now, because this is a quadratic equation, I need to solve it by moving all of the terms to one side and leaving it equal to 0. So I'm going to subtract the 9 over, and it's going to combine with its like term, the 1. So that's going to give me a negative 8. Then I've got a plus 7 times sine of x, and a minus sine squared of x. Now, to solve this, I need to factor. Well, wouldn't it be nice if I had a positive sine squared instead of a negative sine squared? I can make that happen. I'm just going to multiply all the way through by a negative 1 and change all of the signs. Now, you might notice this doesn't factor. Feel free to try if you'd like. At least it doesn't factor easily. So, what I'm going to do is go back and pretend that 9 earlier was actually a 7. And so I'm going to change this 9 to a 7 and that to a 7. So let's back up to this last step. Okay, we'll try this again. So I'm going to, again, try and set everything equal to 0. So I need to subtract by 7 to both sides. That gives me a negative 6. Okay. Now we're going to multiply through by negative 1. It's going to make that a positive 6. And now I'm going to try and factor this. So I need two numbers that multiply together to get 6, but add to get negative 7. So if they're going to multiply together to get a positive, but add to get a negative, I'm pretty sure that means they both need to be negative. So let's start there. And the only two numbers that would work in this case are negative 6 and negative 1. Once I have it factored, I need to set each factor equal to 0. So either sine of x is equal to 6, and we all know that can't happen, or sine of x is equal to 1. That sounds more like it. And so all we need to decide is what angle would make the sine of x equal 1. So what angle has a sine value of 1? Let's check the unit circle. Now sine is the y value on the unit circle. So a y value of 1 would be way up here at the top. And what angle is that? 90 degrees. Okay. And that is the only solution between 0 and 360, as the problem states. So, I leave for you the very similar problem, problem D, right here. So try that one. Again, solve this like a quadratic equation, but you'll need to start by making some sort of replacement right here. Alright, if you have any other questions, talk to me in class. I'll see you then.